Good day, everyone. Welcome to Tagum City National High School Science web course on Science 10, Quarter 2, Force, Motion, and Energy. In this video, we will be talking about the applications of mirrors and lenses. Our learning competency would be to identify ways in which the properties of mirrors and lenses determine their use in optical instruments, like cameras and binoculars. The applications of mirrors and lenses reflect their properties which make them very useful. These properties include the type of image that is formed, the size of the image, the field of view of lenses and mirrors including the image, and the ability to focus light. Okay, one of the most common applications of mirrors is the plane mirror. The plane mirrors are the only type of mirror for which a real object always produces an image that is virtual, erect, and of the same size as the object. This makes it an ideal object for grooming. However, images formed in a plane mirror are inverted from left to right. They are inverse. Of the curved mirrors, convex mirrors provide a wider field of view than flat mirrors, and are often used on vehicles, especially large trucks, to minimize blind spots. They are sometimes placed at road junctions to see around corners to avoid crashing into other vehicles or shopping carts. They are also sometimes used as part of security systems so that a single video camera can show more than one angle at a time. Convex mirrors are also used as decorations in interior design to provide a predominantly experiential effect. Other curved mirrors used are mouth mirrors. These are used by dentists to allow indirect vision and lighting within the mouth. Their reflective surfaces may be either flat or curved. Mouth mirrors are also commonly used by mechanics to allow vision in tight spaces and around corners in equipment. Rear view mirrors are widely used in and on vehicles, such as automobiles or bicycles, to allow drivers to see other vehicles coming up behind them. On rear view sunglasses, the left end of the left glass and the right end of the right glass work as mirrors. Microscopes also contain lenses. Microscope mirrors are a core element of many of the largest high-definition televisions and video projectors. A common technology of this type is the DLP. A DLP chip is a postage stamp-sized microchip whose surface is an array of millions of microscopic mirrors. The picture is created as the individual mirrors move to either reflect light toward the projection surface or toward a light-absorbing surface. The picture formed as light is either reflected toward the projection surface or absorbed by the activated LCD pixels. Large mirrors are used in rear projection televisions. Light is folded by one or more mirrors so that the television set is compact. Mirrors are also integral parts of a solar power plant. The one shown in the adjacent picture uses concentrated solar power from an array of parabolic troughs. Telescopes and other precision instruments use front silvered or first surface mirrors, where the reflecting surface is placed on the front surface of the glass. This eliminates reflection from glass surface ordinarily back mirrors have. A single convex lens mounted in a frame with a handle or a stand is called a magnifying glass. Everybody's so familiar with magnifying glasses. A magnifying glass can be used to focus light, such as to concentrate the sun's radiation to create a hot spot at the focus for creating a fire. Lenses are also used as prosthetics for the correction of visual impairments such as myopia, hypermetropia, presbyopia, and astigmatism. Most lenses used for other purposes have strict axial symmetry. Eyeglass lenses are only approximately symmetric. They are usually shaped to fit a roughly oval or not really circular frame. The optical centers are placed over the eyeballs. Sunglasses, the lenses on the sunglasses, are designed to attenuate light. Sunglass lenses that also correct visual impairments can be custom made. Binoculars or field glasses are two telescopes mounted side by side and aligned to both in the same direction, allowing the viewer to use both eyes when viewing distant objects. Most are sized to be held using both hands, although sizes vary widely from opera glasses to largely pedestal-mounted military models. Unlike a telescope, binoculars give users a three-dimensional image for nearer objects to two views, presented to each of the viewer's eyes from slightly different viewpoints, produced a merged view with an impression of depth. Telescopes. An optical telescope is a telescope that gathers and focuses light mainly from the visible part of the electromagnetic spectrum to create a magnified image for direct view, or to make a photograph, or to collect data through electronic image sensors. The telescope's light gathering power and ability to resolve details is directly related to the diameter of its objective. That's the primary lens or mirror that collects and focuses the light. The larger the objective, the more light the telescope collects and the finer detail it resolves. People use telescopes and binoculars for activities such as observational astronomy when we want to observe the night sky, ornithology, pilotage, and reconnaissance, and watching sports or even performance arts. Microscopes. The most common type of microscopes, and the first that is invented, is the optical microscope. This is an optical instrument containing one or more lenses producing an enlarged image of a sample placed in the focal plane. Optical microscopes have refractive glass to focus light on the eye or onto another light detector. Mirror-based optical microscopes operate in the same manner. Typical magnification of a light microscope, assuming the visible range of light is up to 1,250 times the image. Cameras. The lens of a camera captures the light from the subject and brings it to a focus on the sensor. The design and manufacture of the lens is critical to the quality of the photograph being taken. All cameras use the same basic design. Light enters an enclosed box through a converging or convex lens, and an image is recorded on a light-sensitive medium. Mainly, this is a metal halide. A shutter mechanism controls the length of time that light can enter the camera. This video concludes our lesson about mirrors and lenses. In the next video, we will discuss electricity and its relation to magnetism. See you there.